Hi, we are having a look at some 3D Pythagoras work here. So using the TJ National 5 textbook, we're going to have a go at question 1 from exercise 5.3. So 1a, calculate the length of the face diagonal, e.g. the blue line of this cuboid. So we have a cuboid here. The face diagonal is a diagonal that goes across a face. So it'll go from basically the bottom left-hand corner of this cuboid of this box shape to the bottom right-hand corner. So imagine if we had a book, which we don't need to imagine because we do have a book. So I'm basically looking, this is basically a cuboid shape. So by doing that, we are looking at finding the distance between this corner and this corner. Okay, so back to the question. Okay, so we're not actually doing anything different apart from doing a normal Pythagoras question at the moment. So we are working out the hypotenuse because we have the two shorter sides, and we should of course have a right angle sign in there. So the hypotenuse squared will just be the two shorter sides squared added together. So 12 squared plus 5 squared is 169, which we square root to get 13 centimeters. All right, now on to the new work, so to speak, part B. Now calculate the length of the space diagonal EX. So we're basically going from the bottom left-hand corner to the top right-hand corner. So that's like going from one corner in a room right across the room to the top corner where the wall meets the ceiling at the other side of a room. So if we're imagining this is a room, we've got the bottom left-hand corner of the room. This is going all the way through the middle of the room and up to the top right-hand corner. Okay, so we're not going along the face, we're not going along the walls, we're going straight across the room to the top on the opposite side here. But we have just worked out the EG from E to G here is 13 centimeters. So then we need to look at G to X. Well, how high is G to X? That's 3 centimeters. So we've basically got a right angle triangle there. So 13 centimeters basically all the way across the floor of this room that I'm talking about, and then 3 centimeters up. So there's my diagram. So 13 centimeters across, 3 centimeters up. And again, we're just doing a normal Pythagoras question now that we've thought about that. So 13 squared plus 3 squared, and square root and round the answer to give an answer of 13.3. So again, just go over that one more time. We're thinking of E to G. If we're thinking in terms of a room again, we're going from one corner to the opposite corner, but we're going across the floor. Okay. And once we're going across the floor, we've decided that's 13 centimeters in that very small room, I suppose. And then we're going straight across and straight up. And we'll go straight across from E to G, then straight up from G to X. We're creating a right angle triangle because we're going across the floor, then straight up the corner of the wall. Or the edge of the wall, sorry. So we have a 13 and a 3. So in total, 13 squared plus 3 squared, square rooted, would give the distance from E straight up to X going in a straight line. Okay, so it's all about just kind of being able to visualize that. That's the difficult part of the question. After that, you're just doing Pythagoras a couple of times.